Hello, everyone. My name is Mikhail, and I'm expert on this talk. I'm happy to introduce you Andreas, who is joining Heisenbug Spring from sunny and beautiful Buenos Aires. Andreas, how's the autumn in your city?
Today the temperature it's okay. We are close more or less to the winter, um, so it's a good time to talk about something interesting.
Sure, that's great. Shall we move to testing, right?
Yeah, how many times we use in our application events using I don't know Kafka, AWS, or something like that to communicate our microservices. Some microservices use this event to save information into the database. And here appear a new problem: how I can check if everything works fine or not. This is the idea of this talk.
Sounds really interesting. Before we just really start, I'd like to say something to our audience in Russian. Дорогие друзья, приветствую вас еще раз на Гизенбаге, весна 2024. И перед тем, как мы перейдем к непосредственно докладу, важный момент, который хочется упомянуть. Первое, участвуйте в чате. Все вопросы, комментарии, предложения приветствуются на любом языке. На русском, на английском, на испанском и так далее. Добро пожаловать. Во-вторых, не забудьте, пожалуйста, нажать на кнопку под дискуссией и оставить ваше ревью на это выступление. Это очень важно для спикера, очень важно для конференции, для организаторов. И последнее, приглашаю вас присоединиться к дискуссии, к вопросам и ответам от Андреаса после выступления, и вернемся к выступлению. So, Andreas, I believe we can start the talk today because everything is important already mentioned, and people are joining our chat. So let's go deeper.
Okay, let's start with the presentation. Events a love triangle of integration test. And the titles perhaps sounds like a title of a novel or something like that. It's not the it's not the real problem. The problem behind the scenes it's difficult in some situations. So let me introduce me. My name is Andres Sacco. As Mikhail said, I work as developer since 2007 using different languages. Most of them are connected with the JVM like Kotlin, Scala, and Java. I participate as technical reviewer on some of the biggest editorials around the world. So the editorials or the publishers send me a manuscript about a book, a chapter. I do the corrections. The idea is that this chapter or this book improve the quality before to be published. I also wrote some books and create some theoretical practical scenarios. Some of them appear on the presentation. And last, I participate as speaker on different conferences. You have my contact information, my LinkedIn, my GitHub, my email. So if you have any question after this presentation, after the QA, please contact me. I will try to help you as soon as possible. The context of the situation. So as I mentioned, we have a large number of microservices. Most of them communicate each other using events. So here appear the problems. The problem is because it's difficult check if everything works fine, because I send an event, my application or my microservices process this event, do something, and how I can check if the event was processed okay or not. Because in a common microservices, when I do a synchronic communication, I do an HTTP request, I send parameters and wait until something happen, until that the microservices return a response like everything is okay, fails to process something, it was a bad request, internal server error. This is great in a common scenario, but here it's totally different. I send an event and perhaps nothing happened. How I can check if something changed into the database? Imagine that I produce an event, this event do something into my database, I don't have the possibility to check if everything works fine or not, because again, I don't have an answer, a response of my when I send an event. So I need to find a way to solve this problem. And perhaps when the process finish, a new event was produced, was created and launched to another microservices that need to continue if everything it's fine or not. So at some point you have different scenarios. First, you need to check if the process, if the event was processed okay or not, if something changed in the database, or if you produce a new event. And the main problem with this is that a unit test not cover all these scenarios. Again, because the unit test just is created in a small part of your source code. It's not connected with the real infrastructure, with the real database. You need to create mocks. So here is the problem. Let's see the interaction, because perhaps you say, oh, too many terms, too many things to mention. And let me represent the idea. You have an application which produce an event which another application consume and do something. In the middle, here, not appear, but there is like a broker or some kind of tool that help you to translate this event. The communication is not directly. My application X do something, and after that, save the information in the database and perhaps launch a new event that is use it for another application. This is more or less the problem. Perhaps in your case, some parts of the problem appear or in some parts not exist. Perhaps you don't have you have an application that not persist nothing or don't launch any kind of new events. Why a create a test is so relevant in these cases? Well, first, because it reduces the risk that something bad happened during the process. If I create a lot of things and I don't have an integration test that check if everything works fine or not, the only way that I can test is like, okay, I will start the application locally on my machine and I will try to simulate the context. And perhaps this will affect directly the real infrastructure. This is in the best scenario. In the worst scenario, is like, okay, I will deploy my changes into some environment, some pre-productive environment, and check if everything works fine or not. This is the worst scenario, because we need to check if everything works fine or not before to deploy. You can verify the events, how they produce it, how they consume it. So the relevance is to check if everything in your source code works fine or not, and you need to interact with the real infrastructure, not the real, a fake, but something that simulates the real infrastructure. It's not a unit test because, again, cover different aspects, different communication or different interaction with other components. And I had the possibility to check all the scenarios, not just, okay, I will check if everything worked fine or not in this method, on this function. No. The idea is that you check everything. Which libraries or tools exist? There is a series of libraries or tools. Some are agnostic to the technology, and others are connected with some technology. Let me start with the first one, Test Container. Test Container is a tool, a library, which is agnostic to the language. So you can use it in Python, on Rust, on Java, on Scala. You have different things. And the idea is that you can use this tool to run containers, Docker containers. So if you have a database, if you have, I don't know, a Kafka or a, AWS infrastructure, you can use this library to run a container and manage all the life cycle during your test. So it's a way to resolve or solve part of the problem. Okay, I need to use the real infrastructure. No, you can use test container to do this. The second one is local stack. Local stack is a Docker image which represent more or less all the services that exist on AWS. The idea of this is that you don't need to communicate with the real infrastructure. You can use this to simulate more or less all the different services, SQS, S3, and many other things. Karate is a tool to create, or a library to create different kind of integration test. This library in particular is connected with the JVM languages like Kotlin, Scala, and Java. Of course, you can use it externally to create your end-to-end test or your performance test. There is not restriction, but in the case that you won't use it inside of your source code, like an integration test, this tool only works on Java. So here is the main restriction. And REST-HERT is a tool that provides me access with a REST API to a Mongo database. It's like, okay, I have a database and I have this tool, it's a Docker image, and say, okay, please connect with this database and give me access. So I can access to the database using REST endpoints, which reduce all the problems of like, okay, I need to check if everything on my database works fine or not. Okay, how is the syntax of Karate? Because perhaps this is so complex to understand. And here is an example of the syntax of Karate. It's very, very simple. You define a feature, which is the name of a set of tests. You define everything in the background. It's like the global variables that you will use on all the scenarios, on all your tests. And you have different scenarios. Each scenario represents one test. So in this case, I say, okay, the name of the test of the scenario, and I say, given the path, so the URL that I will do a request using a get method, and I will expect that this request return me a 200 and with that particular response, the match response and the status app. This is more or less the syntax because perhaps not all of you are familiar with the syntax of Karate. Okay, I mentioned a lot of tools. I mentioned Karate. So which are the pros or the cons of using this approach? First, is not you don't affect the real infrastructure. I will not use MongoDB, the real MongoDB on some of my pre-productive environments. I not use the real infrastructure to communicate my events with other microservices just to simulate a scenario of test. It will don't affect nothing. It's simple to verify what happened into my database. So because I have, again, an endpoint that access directly to the database. So I don't need to do some kind of query on and run with or connect on the terminal or something like that. No, you have the possibility to do it. You can simulate events because you have like local stack to simulate what happened to the creation of different events without affecting nothing on the real infrastructure. Most of these tools that I mentioned are agnostic to the language, and why I put the emphasis on or emphasize this part, because perhaps you develop or someone in your company develop application using Kotlin, Scala, or Java, which is great. This solution works in many scenarios, but perhaps you use Go, Rust, or other languages. So you can use most of these tools or this set of tools. You need to find the equivalent to Karate in the case that you use another languages. The main problem with this is that take more time to execute the test because I need to run many containers when I start my integration test. Think that I need to run a database, I need to run this test container, I need to run local stack and many other things. And why I need to do this? Well, because I need to find a way that my tests are idempotent. So I need to find a way that I execute one time, everything works fine. I need to execute again, everything works fine again. If I use some real infrastructure or a dedicated infrastructure just for my test, perhaps the first time that I run my integration test or my test, everything works fine, and the second time, nothing happened, or I have a lot of errors. So take in consideration this kind of things. The main problem with REST herd is that you don't have support to all the database. In this case, only work with MongoDB. And there are another implementation, not of this tool, but there are another tools that represent more or less the same idea with relational database, but are not so popular. So take in consideration that this solution perhaps works just in case for the MongoDB database. How is the process of check if everything works fine or not? More or less have 4 steps. The first one, you need to insert the context, set the context. Okay, I need to send events, populate my database, and I create the context that my test need to check if everything works fine or not. After that, I execute my test. Well, not I. The code execute the test. The last part is check the process, check the results, if everything works fine or not, if the modification are okay or not, if not, if you don't have any kind of error during this process. In the case that, imagine that your microservices, after some process, launch an event. And for some reason you say, I won't check this event. Okay, it's okay, no problem. If you don't want to check if your microservices at the end of some flow launch an event, but you need to remove it, because if you don't remove this event, perhaps will affect other tests. Remember, you start the context, and this context is shared across different tests. So if you don't check or remove the event, perhaps will affect another test. So this is so relevant. If you don't want to check, remove it. Let's go to the example. I put all the code on this repository. Let me go and show you what you will find here. Sorry. You will find this source code or this Git repository. You will have 2 different things. One is the code of the application, and the other are all the things related with Docker, like, as I mentioned, Red Hat, local stack, and many other things. And here you have more or less the requirements that you need to have in your machine to run, how you can check the requirements, some consideration about the ports that this application used to work, and many other things related with the version of the JDK or which tools I use. You have a lot of information to help to set up this context. In the case of this API reservation, there is an application on Java. So I will show you what is this application. This application contains the reservation of a travel agency. And you have here 3 different endpoints. Yeah. As you can imagine, I don't have endpoints to remove or update something, because the idea of this process is do it using events. So I can only create and check the status of the reservation. For example, I execute, and here you have different reservation, and some are confirmed, the status is confirmed, and and other ones perhaps are not confirmed. So what I will do after that, because I show you this API, and as I mentioned, to run or to check everything, I need to execute something to check, to run my microservices. And inside of this GitHub repository, there is a Docker folder which contains a Docker compose. I suggest before to start do something, just run this Docker compose, because if you don't run this API will not work, because you need a database and external services and many other things. So in my case, here are running everything. And let's start with the code. Okay, here is the same repository that I show you. And in this case, I forgot to mention that you have a Postman collection in the case that you don't want to use Swagger to check if everything works fine or not. It's your choice. Let me move to the or load the application. So the first thing that we need to do is add support to Karate, because as I mentioned, we need to create a test. So to do this, let me, we need to add support to many things. Here, I need to add support to Spring Boot test, Spring Boot starter test, which behind the scenes is the thing that use Karate to run my application. And I need to add support to Karate. And here is the main thing. Try to add support to JUnit 5, which is the default standard or the main standard that most of the developers use to create different kind of test. I will refresh my Maven dependencies. And the next thing that I will do is open here the test folder, and here I need to create a test. I have more or less the test created. Before I will show you how it looks like. It's more or less similar that the example that I show, but with a little difference. First, I define here the URL of my microservices. Okay, you need to check on this URL with this path, and you need to add this. And in this case, remember that in the example, in the presentation, there is something like this, which is okay. This is more or less the idea. Don't pay attention to this. This is the example. But imagine that this JSON increased the size a lot. Imagine that you have, I don't know, 45 attributes. So this JSON is use a lot of size, a lot of space on this file. So the best way to do is like, okay, remove it and say, instead to have all the definition of the response here, I put in an external file and say, okay, I will read a file here with the same information. And let me show you. I need to create the directories. Com TWA, because I need to have the same structure of the directories. No, reservation is not necessary. Okay, yeah, refactor. Okay, I need to have the same structure that this. I can put the JSON file, this file with the response here, because on this folder, on the Java folder, only need to have some kind of files that represent a Java thing. So in the case of JSON, I will exclude. I put here, and here you have the same structure. This is everything. So I can run my test and say to check if everything works fine or not. Okay, I don't have any kind of problem. I will close this file. Let me show you the next thing that we need to do. Okay, we need to create like something that represent our flow, because as I mentioned, I create a reservation, and a default reservation have an status. You have the post endpoint. So I will simulate this. And to do this, let me show you. I create this create reservation. And you have more or less the same definition that the previous example. Here I define the URL. I read the request and the response. Instead to put the entire JSON that represent my request, I put in an external file. I read it and I put in a variable. This read function is a default function that exists on Karate. It's not something that I created. And here appear another URL. Don't pay attention now. I will show you in a couple of seconds. So here you have the URL, and I will do a HTTP request. Okay, and everything looks fine. And after I do a post, after I check if everything was pushed inside of my microservices, with the response, I define a variable. Why? Because I want to check if everything is okay into the database. So when I do a post to this method, I will receive a response with the ID. I save this ID, and after that, I do a request to this URL, to this one, this one, with the same ID that I created just a couple of seconds ago, to check if everything works fine or not. Okay, you can think why we can do this, because the idea is show you an example incrementally and not show everything together, because it's like, oh, it's a lot. So I show you Karate, and after that I show how this red heart works. So okay, but after this example, I don't show you how this works. So let me show you. Let me go. Let me show you. Here is the default URL of Red Hat, and when I do a HTTP request, show me the name of the database. So, or the database that exists. If I do click, I will have all the information about all the documents that exist on my database. And here you have the ID. So if you have the ID and put here, you have everything about that reservation. This is the real database. For that reason appeared this name of the attribute. And for that reason appeared the bird, which is a date with that representation, or the class. So this is the same request or the same query that you can execute on your MongoDB database. So I create a reservation, I do a post. imagine that, not think in the context. I create an HTTP request and check if everything works fine or not, and nothing more. To run everything, to run this test, you need to create here a class, which in my case, sorry, I need to create a Java class. This is so important. API test, which you need to indicate many things. You need to say, okay, I want to execute my karate test. And the main way to do is with this annotation, say, okay, this is a karate test, so you need to consider all the scenarios that exist. Previous, I need to say that you need the Java application, the Spring Boot application with this annotation. And after that, you need to define a series of things like, okay, which test I will need to execute, which are the name of the test. To solve this, you need to use this. You need to execute karate run and put the path. In the case that you don't include the path, Java suspect or suppose that you will want to execute all the features that exist on your repository. In this case, because I want to restrict just to some of the test, I will do this. So, sorry, if I run the test again, now we will see that my application start and do many other things. Okay, because I'm running the same application on the same in another part to show you if the application or the Swagger works. I stopped the application and now everything works fine. I forgot to do this. Okay, I have the results here, and now I integrated karate with ResHeart. In a couple of minutes, I will show you how I can configure this. Here appear the results of the execution of my test. If I do click, this need to redirect here, and you have the information about the things that are executed. And here, more or less, you have the times that takes to execute. If you do click, you will have the information about all the steps and how what happened in that part. This gray thing that appear here, which is not green, is because it's a comment. I usually include this comment to split on different sections my test. Great, we have database, we have karate, but we need events. Let me explain first everything about the configuration of ResHeart, because if not, it's like some kind of magic, which is not a magic. So I copy the Docker folder that exists on the root of the repository, and you will find this ResHeart configuration. You will find two different files. The first one is the default configuration. I don't change nothing. I copy and paste the same configuration. And in the case of this ResHeart sham, there is everything, it's the default, but I do some modifications. Here, I need to change the URL or the Mongo URI to access into the database. So this is the only thing that I change. This is the user, the password. This is the local host, but I use Docker, so it's the name of the container, the database, and nothing more. So with these two files, and in your Docker Compose, you have this. This is the configuration to run ResHeart. considering these two files. This is the version that I use. This is the port that I expose. And I say, okay, you depend on another services on this database. This is so simple to execute. Okay, we need to move to another problem, because we have tests, but we don't have events. And remember that I mentioned that we have local stack. And until now, you run the Docker compose, but you don't pay attention to local stack. On the same directory, on this Docker that exists on the default repository, you will find this local stack folder with two different files. The Docker compose, which is there is not some kind of something strange. This is, I create a Docker file, which extends from the default image. I enable two services, an SQS and SQL, and I define some configuration like the default region, which is the name of the local stack, and many other things. But the magic occurs here in the init file, because on the init file, I do many things. I create queues. I have the possibility to push events or check if the events exist or not. So you have a set of methods which execute some commands of the AWS CLI. It's not nothing strange. You can find on many other web pages that have more or less the same logic. In my case, I only change the local stack port, but perhaps you don't find this bash file with this format, but all these commands are so common. And at the end of this file, you will find different things. I define two different queues, one to receive the process of the payment and another to confirm. Remember, I create like a reservation. My reservation have different status. One is created, another is in process, and the last one, when everything is okay, when I receive the money for the client, is confirmed. It's just a representation that you can create many queues. It's not like one queue and I need to check everything on that place. I create two different queues. And in my case, when the application confirm a reservation, everything is okay, the passenger could travel on the flight, and everything looks fine, I will publish a new event to a specific topic. So what I do, I create a topic where my application need to push the results. And this assertion queue, what is the purpose? Because, okay, I push the topic, and on the topic, an event. Remember, we need to check if everything works fine or not. If I publish something to one topic, how I can be sure that the event have the correct format and appear on the topic? I need to simulate a consumer, someone that take the message and check if everything looks fine or not. So for that reason, I create an extra queue, which is assertion queue name, which are connected with this topic to simulate the real consumer of the events that my application publish. Okay, I will close everything, and with this introduction about local stack, let me show you two different examples about this. I will show you just one of them, but take in consideration that exists. Okay, I define the URL of my microservices. I define the REST head configuration. One thing that I forgot to mention. I use this REST head, and perhaps when you, let me go back to this, when you see this thing or this step, you think, oh, where is the response? How I check the response? I do the same thing that here, that I check the response of the request and the response of my API. I do the same. I put in an external file which exists in the resource here. You have the JSON with the same format. Just to clarify, in the case that perhaps I forgot something. Okay, and here you have the URL of local stack. Here is the name of the queue that I created in this init file. So this is more or less the same scenario. I create a reservation, and after that, I need to publish some kind of event to change the status, modify the status. So to do this, I read this file, this external file, which exists here. And this contains more or less the format of a message on SQS, where I need to define here appear. This is because are encoded, for that reason, appear with some strange characters. Don't be afraid about this, but it's a common message of AWS. So I say, okay, I read the file, give me the message, replace, because this the name or the ID of my reservation is dynamic, so I need to change. Please replace on this event or this message, replace and put the correct ID. So with this in mind, okay, do a request and post. Do a post with this body on the local stack. And what I will do after that, because I create a reservation and I publish an event. Okay, looks great. But remember, this is an asynchronic communication. So I can't wait and say, okay, wait 1 second or wait until that I have a response. No, it's not possible because it's asynchronic. So with this in mind, I will say, okay, retry 10 times with that 3 seconds of intervals, or between each request takes 3 seconds, and check if everything looks fine into my database. So, okay, run, send event, and instead to say, okay, I will wait a second, it's like, okay, retry, do a HTTP request to Red Hat 10 times and wait in between the different requests 3 seconds. Okay, so with this in mind, I have local stack. I have many other things. So I will execute again, and after that, I will show you quickly how you can integrate with local stack. Test container. So remember that this takes time to be executed, because need to check if everything works fine or not. Okay, everything looks fine now. Just a couple of seconds. I don't know why I don't have the new report. Because I don't add on here. Okay, to don't lose more time, I will show the final solution. I will create a new class. Sorry, it's not this new package, util. Yep, which will contains many things like the Docker Compose and the test container. Sorry, And what is the idea of the Docker Compose? Remember that I configure everything on my Docker Compose image, which resolve many other things. So why I can use or reuse this logic? So with this in mind, I will create a new class which say, okay, use test container and read this file, execute all the services, the same thing that you can do when you execute Docker Compose app or Docker Compose run, and wait until that local stack are okay. This is a way to say, okay, wait until that this service have this message, and in the case of the database, do the same. And when I before to execute all my tests, please start the container, and when you execute all the tests, please stop the execution. Okay, let me do the modification here to add all the tests. And to summarize this, I need to do two different things. First, I need to add the support to test container here. With this library, I have support to test container. Okay, I need to refresh. For that reason, this base test failed, and now it's okay. And the second, I need to stop everything here because I want to execute my test on my terminal. So I will do this. And whoa. I think I missed something. Whoa, disappear all my Docker Compose file. Here. I don't know why, but disappear. Okay, and after that, I execute a Docker Compose. Look like this appear a Docker Compose file. And if I check on my Docker desktop, here appear a lot of containers that will are executed at the same time. When the test finish, everything will close. Now, everything is stop. And okay, my tests are finished. Okay, let's summarize my talk. Best practices. Check everything, check the events, check the database, and if everything works fine or not, remove the events or check the events in the case that you prefer to don't produce that like side effect. Right, simple. The test to be simple to understand, and use container, not use the real infrastructure. Some additional resources, books that you will find more information, and blogs. And that is the end of my presentation. Thanks to everyone to assist.
Yeah, Andreas, thanks so much for the detailed talk. It's rather was a workshop rather than a regular talk, which is always welcome. We love practice and real life examples. Also, a few words for our audience. Друзья, напоминаю, что принимайте участие в чате. Также сейчас мы перейдем с вами в дискуссию. Присоединяйтесь, там как раз будут ответы на вопросы и какие-то дополнительные обсуждения. И, пожалуйста, не забудьте оставить фидбэк. Это очень важно для Андреаса, для нас, как организаторов конференции, и для вас самих, потому что в следующий раз будет что-то, на что вы обратите внимание, или, наоборот, этого не будет. Yes, so we are joining the discussion zone because we are out of time here and we can answer all upcoming questions.